Hello dear students, are you facing any difficulty in solving the problems given on parallel combination of resistances? If you say yes, then you need to learn some of the basics which are related to a circuit which consists of several resistors in parallel. Which are those basics then? Those basics are the behavior of current and the behavior of potential difference and the equivalent resistance in the circuit across the combination and through individual resistors. Let us take an example of the circuit which is already mentioned in your textbook. Here two diagrams are drawn. In the first diagram, what circuit we have taken, same circuit we are considering in the second diagram also. Here, in first case, we are measuring the potential difference and the current across this combination, through the combination and across the combination. Whereas, here potential difference and current we are measuring through and across each resistor here, individually. First, let us take the first diagram. In this diagram, resistor R1, R2, R3. These are connected in parallel and a battery is connected, a plug key is connected and an ammeter, it is connected in series. Right. Now, a potential difference. To measure the potential difference, a voltmeter is connected across the ends of this combination of resistors to the terminals X and Y. In the beginning, after inserting the plug key, we have to measure the current through ammeter. It gives certain value of current, let it be I. Now, coming to the potential difference, voltmeter reading when you take down, it gives certain value of potential difference across this combination of resistors. That potential difference we are taking it as phi, right? Now, coming to the second case, here. Now we are connecting the potential, means voltmeter, across the terminals of resistor R1 to measure the potential difference across this, and an ammeter is connected in series with resistor R1. Now we have to note down the reading from the ammeter. It gives certain value of current, that is I. That I may be any value. So let us call this current as I1 since it is related to R1. Now the potential difference, it is coming phi. Now taking the resistor R2, we have to again measure the potential difference. Now also we get the potential difference phi. And the current will be, this time it will be I2. Means what? Current is changing. And in third case, when we measure the potential difference again, we get the potential difference again phi, same as it is. Here current will be I3 this time. Now we can observe here. What do you think will be the value of potential difference across each resistor here? Here potential difference across each resistor remains same, because here let us take an example of the syntax for that. If the taps are connected surroundingly, each tap experiences same pressure of water since they are directly connected to the source of water there, that is to the syntax directly. In the same way, here all the resistors, since they are directly connected to the source of electricity, that is the battery, they are receiving the same pressure of electrical charges, electric current. So each resistor experiences same potential difference. Whereas current varies. Why it divides here current as I1, I2, I3? Because here each resistor, it is having its own capacity to oppose the flow of electrons. That is only resistance what we are saying as 1 ohm, 2 ohm, 3 ohm, right? So based on that, it is opposing the flow of electrical charges through it. So that is why it is allowing certain amount of electrical charges. That electric current we are considering it as I1. Similarly, R2 to the resistor 2, it is also allowing certain amount of electrical charges, electric current flow through it. That is taken as I2. Similarly, R3, it is giving the current through it, I3. Okay. Now, in this what we understood, the potential difference remains in the equivalent resistance it may be, or through each individual resistor it may be. Potential difference does not change, it remains same. Now, what happens to the current? Here, current through this combination is different. And here, when we take individual resistors, when we take, that current will be coming in the form of I1, I2, I3. From this, we can deduce a relation for this current of equivalent resistance and individual resistances. When we derive that relation, when we deduce, what do we get? the total current through the combination of these resistances which are in parallel will be equal to the sum of current through each branch of these what resistances in parallel. Means what? Through R1, through R2, through R3. How much current will be flowing? When we do the sum of these currents, that sum will be equal to the current through this combination. So that is what we are writing here in the form of an equation, that is I is equal to I1 plus I2 plus I3. I is equal to I1 plus I2 plus I3. Let us call this as equation 1. Now here all these resistors can be replaced by another resistor which is having the value which is equal to the sum of the resistances of all the three resistors. That is called equivalent resistance. That equivalent resistance, let us take it as Rp. Since those resistances are in parallel, let us take that as Rp. Now, by applying Ohm's law to this resistor, what do we get? I is equal to phi by Rp. This is by Ohm's law that we already studied in the previous class, right? Now, let us try to apply the same Ohm's law to individual resistors R1, R2, R3. When we apply, here, this becomes now, according to Ohm's law, I is equal to, instead of I, we are taking it as I1 now. And phi by R, we are not taking, R1 we are taking, since it is resistor 1. So, I1 is equal to phi by R1. Similarly, with respect to resistor 2, I2 is equal to phi by R2 we get, as we have already written there. And for resistor R3, we are getting I3 is equal to phi by R3 we are getting. Let us call this as equation 2. From equation 1 and 2, see what we are doing here. I is equal to phi by Rp. So in place of I am writing phi by Rp. Phi by Rp I am writing here. Phi by Rp is equal to I1. In place of I1, we will write V by R1 plus I2. In place of I2, phi by R2. In place of I3, phi by R3. After writing all these equations, substitutions, we are getting phi by Rp is equal to phi by R1 plus phi by R2 plus phi by R3, right? Now let us keep phi outside the bracket and take inside the bracket 1 by Rp. It remains. And here also phi is common everywhere. Let us keep that phi outside. Inside the bracket 1 by R1 plus 1 by R2 plus 1 by R3 it remains, right? Both sides, since potential difference is there, they get cancelled, right? Here phi it gets cancelled. What remains? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This relation we are getting here. From this, we may conclude. What we can conclude? See, the equivalent resistance, the reciprocal of equivalent resistance of a group of resistors which are in parallel is equal to the sum of the reciprocal of individual resistance. So this is what we are learning from this circuit. Okay, this is practical circuit. Once if you understand these basics, you can solve any type of problem which are coming into your exams, it may be in textbooks. I hope you understood this. Thank you.